In this video, I'll be working on your Chapter 10 test review. This is on page 712. As we've already worked on the actual review problems, I'm just going to work on the chapter test that is at the end of Chapter 10. So, number 1, I would have to know that a point outside of a circle creates two congruent tangents. So I should be able to see this ice cream cone and set the two pieces, the two tangents, congruent. So I'd get subtract 3x from both sides, add 4, 2x equals 10, x equals 5. Alright, and that would make sense if I would plug it back in. Number 2, I would know that I have a tangent line right here. It just simply touches the circle. So that means it does create a right triangle. So if I were to use the Pythagorean theorem to try to figure out r, I would have r squared plus 12 squared equals r plus 6 squared. I would have to FOIL my right side, which would give me r squared plus 12r plus 36. R looks weird. R squared plus 144. I would combine my like terms and try to move everything to one side. So I subtract the r squareds, and I'm left with 12r and 36 minus 144, which is minus 108. Alright, so then I would solve for r. Since it's just r, I'd just move my constant over to one side. 108 equals 12r, and that would come out to r equals 9. And this would make sense. It's positive, so your radius is worth 9. Number 3, I would have the same thing, my nice little ice cream cone with my two tangent lines here. And I would know those are congruent, so I'd have 2x squared plus 8x minus 17, so I can set their values equal. Equals 8x plus 15. Combine my like terms, subtract 8x from both sides. And if I go ahead and add 17, I just am left with 2x squared on this side. Add 17, that gives me 32. Divide each side by 2, x squared equals 16. And take the square root. I would get x equals plus or minus 4. However, if I plug in the negative 4 times 8 plus 15, I am going to get a negative value, so that actually rules out the negative. So x equals positive 4 is my only actual solution. The other one is what is called an extraneous solution. Alright, number 4 on this, the directions ask tell whether the red arcs are congruent and explain why or why not. So here I have my center point, and I know that a central angle makes the measure of the corresponding arc congruent. So if that arc and that angle are congruent, alright, so they're all 60 degrees. So I know that because of one of my theorems. For number 5, I actually have two separate circles, so I need to know that they're the same size. So their radius is 5. Alright, and I need to know that the arcs. So here, central angle is 136. So that means that is 136. Here, 224, if I take that away from 360, then I know that this arc is going to be 136 degrees as well. So that means that they are both congruent. And in number 6, I'm strictly looking to see if their measures are the same. This is number 6. You can see right away that the radii of the two circles are not congruent, so that means that those arcs are not going to be congruent, even though they both correspond to a 119 degree central angle. Moving on to number 7. Number 7 asks, determine whether AB is a diameter. So I need to figure out what all I know. So a diameter is a perpendicular, so it's perpendicular, so it's a chord, bisector. I do have 8.9 and 8.9, so that actually checks out. So this AB here, AB is a diameter because CD is bisected, and I am given that right angle. Number 8, it is a bisector. Number 8 is a bisector. and it does give me, in addition, that this is 90 degrees. That means this angle would be 90 as well. So I have a perpendicular bisector. That means that AB, again, is our diameter. And on this last one, I have an inscribed right triangle. So I can go ahead and solve for this missing leg. It's a 3, 4, 5 right triangle with a factor, a scale factor of 5, so that would be 3 times 5. So that would make this 15. So it is perpendicular, however, these two pieces are not congruent, so it's not a bisector. I have 14 and 15. So for number 9, it is in fact not a diameter. Moving on to number 10, the directions ask me to find the indicated measure, so it wants me to find this angle. Well, it is inscribed angle, which means that I would take 106 degrees and I divide that in half. The angle is going to be smaller than a central angle would be. Keep that in mind. So that means 100 divided by 2 is 50, and 6 divided by 2 is 3, so that is 53 degrees. Number 11, it is the same concept, however we're given the inscribed angle instead of the arc, so I would take 82 degrees and multiply that by 2 and get 164 degrees. Number 12, it's very similar, where I would go ahead and find JG or GJ, and that would be 86 degrees. However, it doesn't ask for that. It asks for GHJ, so I would have to take that away from 360 degrees. So 360, take away 86 degrees, and that's going to give me 274 degrees. 274 degrees. For number 13, it asks me to find this angle right here. And we are given this piece of the arc. There is a theorem that says if I have a tangent line that intersects with the chord, then the angle created is 1/2 the measure of that arc. So I would take 238 divided by 2. 200 divided by 2 is 100. 38 divided by 2, well, 30 divided by 2 gives me 15, and 8 divided by 2 is 4, so 15 and 4 is 19. 119 degrees for this angle, and that does make sense. It is over 90. 90 degrees would be right about there, so it should make sense that that is 119 degrees. For number 14, if I'm trying to find that interior angle right there, I need the two arcs that correspond to that, so 52. I add them together and I average it out, divided by 2, so that gives me 164 divided by 2, which is 82 degrees. Alright, and it does look less than 90, so that does make sense. For number 15, we have to do a little bit more work. So when we were finding the exterior angles here, interior I add, and exterior I subtract. So I use these two bits of arc, and I subtract the smaller bit from the larger bit. So I would be taking away the red from the blue. So 168 minus, I'm just going to go ahead and say right here, x, alright, subtract x, that's what we're trying to find. And if I divide by that by 2, I would get 42 degrees. So my first step is to multiply by 2. 168 minus x equals 84. And then I'm going to move x to the other side in 84. So 168 minus 84 equals x, which equals 168 minus 84. It's going to be 84 degrees. Alright, so x is 84. Alright, number 16. If I have two chords that intersect, each of their segments, the product of their segments that make up the chord, is equal to the product of the segments of the other chord. So 4 times 14, that's one chord, 4 times 14, should equal 8 times x, 8x, and 4 times 14 is equal to 56. 8x, divide by 8 on both sides, and x equals 7. Okay, and number 17, I would have to remember that I take the outside piece multiplied by the entire secant is going to equal the tangent squared. So 9 times the entire secant is 9 plus x, and that will equal 12 squared, so the tangent squared. So I have 144 is equal to 81 plus 9x, and this is a two-step equation, so you take 144 minus 81, 9x equals 63, and x equals 7. Okay, number 18, it's very similar to 17 where you're taking the outside piece times the entire. So I need to take x times 28 plus x, and that should equal 20 times 22 plus 32 is 52. Alright, so 20 times 52 is 1040, so I get 28x plus x squared. And I'm going to go ahead and put everything on one side nice and neatly. So x squared plus 28x minus 1040 equals 0. So this is where I would have to factor. I'm looking for products that multiply to give me negative 1040 that add to 28. I could also use the quadratic formula if I knew how to do that. However, let's break it down into a couple of factors that might be big enough and create a big enough difference. So off the top of my head, if I start with negative 10 and positive 104, or negative 20 and a positive 52, this would give me 32. This would give me 94, so I'm getting a lot closer. And if I just type into my calculator 1040 divided by, alright, I need it to be a little bit higher than 20, so 21, and then 22, and then 23, I would see that it actually wouldn't work out. So let me actually work through another example for you guys in which you would be able to factor. Alright, here is my number 18 substitute. This is actually number 8 on page 693. Alright, so we need to remember our theorems. Everything that's outside of the circle, we are multiplying by the entire secant or the entire tangent. So I need to take my outside piece and multiply that by 4 plus 5, so my entire secant, and my x minus 2 piece multiplied by my entire secant, which is x minus 2, I keep writing plus, x minus 2 plus x plus 4. Alright, so I need to make sure I combine my like terms. Alright, so this ends up 4 times 9, which is 36 on the left side. And this is still x minus 2. Combine my like terms, I'm just adding across. So this is 2x plus 2. And I will 100% have to FOIL this. So this would give me 2x squared from my first term, outside and inside, plus 2x minus 4x. Plus 2x minus 4x is minus 2x. And my last term gives me minus 4. Now if I go ahead and combine all of my terms, for 0 on one side, 2x squared minus 2x minus 40, I do see that they all have one number in common, and that is 2. So I'm going to go ahead and divide everything by 2, just to make it easier on myself. X squared minus x minus 20. Alright, well, what factors a 20? Add to negative 1. And that would give me x minus 5, x plus 4, which would then make x equal to 5 and negative 4. However, if I plug in negative 4, I would get negative 6 here and 0 here, and that doesn't make sense, logically speaking, when we're talking about length. So then x equals 5 would be my only answer for that. And now I'm going to go back to my previous slide for number 19. Number 19 on the review, or the chapter test, it says find the center and the radius. Alright, given this standard equation right here. Well, our center is given by the h and the k, depending on what's plugged in. If it reads plus, that means it's actually negative, because in our formula it's x minus h. So that means I plugged in a negative. The double negative makes it a positive, so it's a negative 2 and a positive 5, so that is my center. And my radius is equal to the square root of 169, because r squared is on this right side here. R squared equals 169. I took the square root of that, and my radius would be 13. So those are your two pieces for the answers. Please feel free to see me early in the morning with questions.